Now we've reached the point where we can finally solve an IVP using Laplace transformations. Okay, so the example is going to say, solve the following IVP. Okay. Solve the following initial value problem. Okay. And you'll notice that a few things about the initial value problem that need to be there in order for you to use Laplace transformations. Okay. So the problem we're solving is y double prime minus 10y prime, okay, plus 9 times y equals 5 times t. And the initial conditions for the initial value problem, since it's second order, is y of 0 equals -1, okay, and y prime of 0 is equal to 2, okay. The big thing to recognize is with Laplace transformations, it's the initial condition of 0 that is necessary, okay. That's a necessary component. Without that, Laplace transformations can work, but there's a bit more work that needs to be done. What you would have to do is formulate the IVP in such a way that it starts at 0 and then you have to adjust your initial conditions and your output. So let me go ahead and put things straight for you guys. A Laplace transformation does not require that your initial conditions start at 0, but it makes it a whole lot easier with respect to the definition. All right? And we may or may not get to an example where I show you guys how to do that, but I might be able to on Thursday. So stay tuned, but I just want you guys to know it doesn't have to start at 0. So if I said that, please forgive me. What it means is you would have to transform it to a special type of linear equation in order to adjust and recenter the initial condition around 0. Okay, so that's the correction I want to make sure you guys know. And so let's go ahead and get started and finish out this example. So anyway, the first step in using a Laplace transformation to solve an IVP is to take the transform of every single term in the differential equation. So literally, what you'll do is Laplace transformation of y double prime, okay, minus 10 times the Laplace transformation of y prime, okay, plus 9 times the Laplace transformation of y, okay, equals the Laplace transformation of 5t. Okay, and this one probably looks the most familiar to you guys. You know how to solve that one right away. What's not so familiar is how you take Laplace transformations of functions themselves. We derived that previously, so now we have to put that into practice. So first of all, I want you guys to know that the Laplace transformation of y is simply just y of s. Okay, that's taken straight from the definition up above, which was right here. And so if it was just y, that means n equals 0. And so there is nothing to take the derivative of, and you're only left with s to the 0, which is 1 times y of s. And so we have y of s, or f of s if the subscript was f instead of y. So make sure you guys can see that from the definition. So now let's go ahead and expand this newly transformed expression into what it actually looks like using what we derived previously. So first we'll start with the second order term. That's going to be s squared, okay, times capital Y of s, all right, minus s times y of 0, okay, minus y prime of 0, all right, and that is just for the first term with respect to the second order. So now we do the next version, which is minus 10, and this is for the first derivative, the Laplace transformation for the first derivative. So minus 10 times s times y of s, okay, minus y of 0,